Hi class, welcome back. Today we're going to discuss inverse trig functions and differentiation. The objectives are to develop properties of the six inverse trig functions, differentiate an inverse trig function, and review basic differentiation rules for elementary functions. So we have discussed already the inverse of a function, and so the way it ties in this it ties all together is we're going to see this in this section and in particular problem that I do at the bottom, where even though we know how to find the inverse of a trig function, the problem here is that we didn't know a rule that we can use to come up with for the derivative of inverse function. Now, with the result that we used previously in previous section, we're going to be able to come up with a rule, and so that's how it fits all together here. Right. So none of the six basic trig functions have an inverse function. That's actually a true statement, because all six trig functions are periodic and therefore are not one-to-one. They fail the horizontal line test. So in this section, you examine these six functions to see whether their domains can be redefined in such a particular way, such that the inverse functions will be restricted with their domains. Under this suitable restriction, now each of these six trig functions will be one-to-one, and so it will have an inverse function, as shown in the following definition. The definition of an inverse trig function is as follows. The inverse of a sine function is going to be arcsine. And what we're going to say here is the domain of this arcsine will be between -1 and 1. And the range of this will be between negative pi over 2 and pi over 2. Do you guys remember that this is exactly the range of this function, and this is exactly the domain of the sine function? So remember what we said is that they interchange, right? You interchange them, and that's how we were able to figure out. So I don't recommend you guys memorizing this. I want you guys to be familiar, but all I do I just remember the domain and range of the sine, and remember that that's actually very easy to find, right? The sine function, it goes like this, right? And it's periodically, it goes for -infinity to infinity, right? But what we did last time was like, okay, we're gonna restrict it. We're gonna restrict it so that it starts at the so it goes from negative pi to pi, and then if you notice, the range is from +1 to -1, right? So that's the range of a function, of a sine function. So that's where all this is coming from, right? And a similar way, we can use that argument to redefine the arc cosine, which is the inverse of a cosine, and the domain will be -1 and 1, and between 0 and pi. For the tangent, is very similar to the sine. The domain will be from -infinity to infinity, and the range will be the same, negative pi over 2 and pi over 2. Now, I remind you guys that we sort of seen this before in our trig functions, in our trig class. And so this is sort of like a review, right? And this is an arc cotangent. This is the inverse function of a cotangent, where the domain of an arc cotangent will be -infinity to infinity, and the range will be 0 to pi. And so on and so on and so on, right? We have all the other ones as well. But here's a better way to see it, right? In the first case, we have a arcsine, So the arcsine is limited to be between -1 and 1, and the lower bound and upper bound will be negative pi over 2 and pi over 2. Vice versa for the arc cosine, it's going to look like this. It's going to go from -1 to 1, and it's going to go from 0 to pi. For the tangent, arctangent is going to go from -infinity all the way to +infinity, and it will be bounded between pi over 2 and negative pi over 2. All right, and vice versa. You guys will see here that this is just the way this looks like, right? It's going to be they're going to be restricted, and the domain for this one will be from negative infinity to negative 1, and then from 1 to infinity, and be bounded between negative pi over 2 to 0, and then from 0 to pi over 2, and vice versa, right? So our goal is to be able to for this section is again to review basic rules for our trig functions, and then be able to find a derivative. So let's go ahead and practice, or in other words, review some of the trig functions rules to evaluate a function. So the first one is asking us to evaluate the arcsine of negative 1/2, right? And if you guys ever get confused here, remember that when you take the sine of something, you take the sine of an angle, right? So this tends to be an angle, and the result happens to be a real number. Well, when you're doing this for arcsine does the opposite, right? It's going to do a real number, and the output is going to be an angle, right? So this makes sense, right? This is a real number, and the output will be an angle. So the output will be an angle, the output will be an angle. And so that's sort of kind of like the way I kind of tell my students to see this. What we're going to do is we're going to say, okay, let's go ahead and since we're looking for this, right, we're going to try to, we know it's arcsine. We all know that we're not very familiar with the values of an arcsine, and you shouldn't be familiar with the values of arcsine, but you should be familiar with the values of sine. So what we're going to do here is we're going to transform this and rewrite it in terms of sine. I hope that kind of makes sense. And how we're going to do this is very simple, right? We're going to let this be y, right? So we're going to let y equal arcsine of negative 1/2. And then from here, you're going to try to get sine out of this, right? So you want to actually use, you want to undo this and have everything in terms of sine. So what I'm going to do is I'm going to take the sine on both sides of the equation. Do you guys see that? So the sine of the left side and the sine of the right side. And we can do that, right? And you can always do this as long as you're doing it on both sides of the equation, and as long as you're not getting an undefined result. So that makes sense. And why we're doing this is, and why we are doing this is because these two will undo each other, leaving you back with negative 1/2. And now this is better. This gives us sine negative 1/2. So we just find out that sine y is negative 1/2, but that's not the answer, right? Our answer is to find what is the value of y. And again, what is the value of y? Y is an angle, right? So what we're going to do is you're going to ask yourself, what angle y gives you sine y equals negative 1/2. That means that when you plug in the angle here in your head and you apply the sine to it, that should give you negative 1/2. And so what we're going to do here is we're going to refer to the unit circle. And you're going to see what angle in the unit circle gives you a sine of negative 1/2. Well, it's negative, so it must be on the denominator. We know that here sine is 0, here sine is negative 1, sine is 0 over there. So we're going to say, oh, well, it's going to be here, and there. right? So here, you're going to have your sine be negative 1/2. And then your cosine, obviously, it's going to be negative square root of 3/2, but that's not the point. Okay, right. Now the question is, what's the angle that we? So two questions you have to ask yourself. There's two options. One of them is going to be your answer. So you have to choose which of this angle, right, will give you the right answer. And then also, how do we find this angle, right? So first thing is first, let's figure out which of these two angles is going to be the solution. Well, I remind you here real quick that your angle for this, the range of a sine, and the range of an arcsine needs to be between negative pi/2 and pi/2. So that means that you can only make an angle that is here and here, between those two, between this range right here. So that means positive pi/2 and then negative pi/2. So that means that this angle will not work, and so we're going to be using this angle right there. So let me move that out of the way. We're going to put and cross this one, so that's not going to be the one. So we're going to be this angle. So this angle, we cannot use it this way because that will be outside our range. So we have to use it this way, right? So let's go ahead and do that. We're gonna so I remind you that this right here will give you 1/2 for a sine, and that angle happens to be pi/6. So that means that this angle here will be negative pi/6, and that's how we found our value. So the angle, so the arcsine of this is pi/6. All right. So I hope that kind of helps you guys with this. So there is no direct way you can do this. When you guys are doing this in the test, the expectation will be that you guys are not using your calculator to come up with these. You'll be using your unit circle. So unless it's specified to use your calculator. Anyway, so you guys will see this approach. I'll do that approach again. So let's try example B. Find the arc cosine of, and I'm going to erase a few things here just to make this to make my notes clean, but I hope you guys are able to write it on your own. Okay, so the next one will be finding the arc cosine of 0. And it's going to be the same argument. We're going to do the same argument. We're going to let this equal y. So we're going to say y equals arc cosine of 0. I'm sorry, that's a 0. Now remember, this is an angle. This is a real number. So what we're going to do is we're going to apply the sign on both sides of the equation. Remember, this is how we did it in trig. Oh, sorry, and I used the wrong one. Oopsie, I meant to use cosine, right? Obviously. All right, our cosine of 0. Okay. All right, so we gotta match those two, right? All right. So what happens on the left side? Nothing. What happens on the right side? You get 0. So you have to find in the unit circle, right? You gotta find in the unit circle the angle. Right? You're looking for the angle that when you apply it to the cosine, it will give you 0. Remember that the angle here and there gives you cosine of 0, right? Those two angles. Now remember that the domain, the range of our cosine is between 0 and pi. How do we know that? We know that from the trig, but you can always make reference to this, right? All right, and then so therefore this is outside the range because the range needs to be here and there. So that means that the only value that this is going to give us cosine of 0 will be this angle, which is pi over 2. So y equals pi over 2. There you go. All right, next one. All right, and I'm going to erase this. All right, so on the next one, we'll do the same thing. We're going to take the arctangent of this. We're going to let y equal this. Again, because we don't know what arctangent, we're not familiar with the values of arctangent, so it makes logical sense to transform this in terms of tangent. Okay, and it's very easy, right? We just have to undo the arctangent by applying the tangent on both sides of the equation. So tangent of y on the left side equals the tangent on the right side. These will undo each other, and therefore we have tangent of y equals the square root of 3. So the square root of 3 happens, we have to sort of relate this to the unit circle. And remember that this is supposed to be sine of y over cosine of y. Well, this can be manipulated so that we can say, well, we could divide this by 1, right? And we still have the same value. Well, what about if we divide both top and bottom by 2? That's still the same thing, right? Because we're doing the same thing top and bottom. Well, that suggests that your sine is the square root of 3 over 2, right? The square root of 3 over 2. And the cosine is 1/2. So that gives you two options, right? This gives you the option of having the square root of 3 over 2 will be somewhere in here, or also either the fact that we put a minus in front of it, it will give you this one over here. So it'll be this angle over here. But remember, as we said before, the tangent happens to be between negative pi over 2. The range of arctangent needs to be between negative pi over 2 and pi over 2. So it needs to be in this region, right? Oh, sorry, my bad. I meant this region. Oopsie. All right. So therefore, obviously, this does not make sense because that's not going to be the angle that we're looking for. It's going to be the other angle will be the right solution. So therefore, we're going to go ahead and find that, and it's obviously that the angle is going to be pi over 3, right? Because that's the angle that will give us this the angle that will give us positive square root of 3 over 2, sorry, 1/2 square root of 3 over 2. So cosine, sine. Okay. So there you go. We found pi over 3, and that's the only solution that we need. All right, the next one is asking us to do the arcsine of 0.3. So for this one, if you notice, the number is already a decimal. So for this one, we're actually going to use a calculator, right? This is the opportunity where we actually use a calculator, and we can use a calculator. All we have to do is type it into our calculator, and using we want to make sure that our answer is in radians. We're going to do it in radians, so we're going to go ahead and do that. So let me bring out the calculator here, and I'm going to do arcsine. Oh, well, first let's check my mode is in radians. So where is this? This one looks definitely different than the other one. So right now, if you guys notice, this is in degrees. Degrees are highlighted, so I'm going to change it to radians. Once I do that, I'm going to close my window, and then I'm going to do arcsine. So arcsine is the hyperlink over here. So the upper option. So I have to do second, and now I'm going to click I think it was cosine, arc cosine, and I'm going to plug in 0.3, and then press enter. And I think that was the number we're looking for, right? That was oops, sorry, we were looking for arcsine. Let's try this again. Sine arcsine 0.3. There you go. All right, so we got the number, right? So we were looking for arcsine, not arc cosine. Good. All right, so I hope you guys found this refreshing, or reviewing this. That gave you guys a nice a quick review of how we evaluate some of the trig inverse functions. All right, so I want to remind you guys that the inverse functions will undo each other with the original function, right? So we want to re-emphasize some of these properties in the following table. We want to remind you that when you have a sine arcsine, they're going to give you back x, or if you have arcsine sine y, they're going to give you back y. Now it's key for us to understand what the value that we're plugging in and what's the value that's coming out. What are these numbers? What do these numbers represent? So it's actually, they're not the same values. X and y are not the same values. If you guys think about this for a second, it totally makes sense. Because remember that here, you're plugging into the arcsine. Now arcsine, you plug in real numbers. And as a result, the output is an angle, right? Because that's what we're going to use for the sine. So this is a real number, and the real number will stay between -1 and 1 for our trig inverse. And therefore, what we're going to have here is a result is going to be a real number. Versus when you have arcsine sine y, y is an angle, right? Because that's all you can put in, right? It could be an angle in the form of degrees, or an angle in the form of radians. Either way, it's an angle because you're plugging it into the sine. You can only plug in angles into sine. So that means that when you plug in the angle, the end result will be a real number. But then when you apply the arcsine of it, it's going to give you back an angle. So what I'm saying here is that this is an angle for which y stays within those two. And I hope that kind of makes sense, right? So when we're talking about domain and range, we are interchanging back and forth between whether we're talking about the original function or the trig function. Similar argument for the arctangent. Right here, this is a real number, so the output is a real number. Here is an angle, so the output is an angle. Same thing with the arcsecant. This is a real number, the output is a real number. Here's an angle, the output is an angle. All right. So this will help us. Again, these identities help us solve any trig equation for now on, right? And it sort of follows the same argument that I've done before, right? I try to be consistent with the undoing what's being done to the function. So let's solve the next equation, right? So we have the arctangent of 2x minus 3 equals to pi over 4. And technically it makes sense, right? Because here, this is supposed to be a real number. When you apply the arctangent of it, you should get a real an angle, right? So it makes sense. It could be a radian in the form of a decimal, right? That's still fine. So what we're going to do here is we need to solve for x. but we notice what happens to x is being multiplied by 2, then subtracted by 3, and then you're applying the arctangent. So to get to the x, we need to undo this, then this, and then this. Well, before you can get there, you have to start from the outside. So you have to remove this first to be able to start removing this and then removing that. So what we're going to do is we're gonna undo the arctangent, and the only way we can undo the tangent is by applying the tangent on both sides of the equation, right? Whatever you do on one side, do it to the other side. These will cancel each other out, giving you back whatever's inside, and then you can apply the tangent of the pi over 4, and that will give you 1. And then you're going to add 3, and that gives you 1 plus 3 is 4. So we'll write it here, 2x equals 4. And then we can divide both sides by 2, and that will give us 4 over 2, which is 2. And there you go. And you can always test it back, right? You can plug it in here to make sure that you get that it is a true solution. All right. Anyway, so we're moving on to the next part, which is the main thing of this section. Our goal is to be able to differentiate inverse trig functions. So what we're going to do here is define the rules for differentiating inverse functions. And so here are the 6 rules. So if you want to do the derivative of an arcsine where u is a function of x, right? So you're going to have to use chain rule. Then what you're going to do is going to be 1 over the square root of 1 minus u squared, and then multiply by the derivative of the inside. For the arc cosine, it will be very similar to that. It's almost the same thing, right? 1 over the square root of 1 minus u squared over negative 1, right? Times the derivative of the inside. For the arctangent, it's going to be u prime over 1 plus u squared. For the arc cotangent, it's going to be negative u prime over 1 plus u squared. And for our secant, it's going to be u prime over u factorial times the square root of u squared minus 1. And then, so if you guys notice, I want to point this out. These and these are the same thing, right? Do you guys notice that? Except that this has negative on top of it. So do you need to memorize all 6? No. It just makes logical sense to memorize or be familiar with these ones, and you can generate these, right? So we're going to use these formulas to come up with the rules. Now I will explain how these formulas are developed. So I'll explain that at the end of the lecture. But for now, just know that you can come up with these ones on your own, and I'll show you guys how you do that. All right, but we're given to you here, so for reference. So the derivative of arcsine 2x, we're gonna have to choose which rule we're gonna use. So it's gonna be obviously this one. So we're gonna identify what's u. In this case, is 2x. So we're gonna do 1 over the square root of 1 minus u. When u, in this case, u is 2x. So we're gonna square your u, right? Which is 2x. Don't forget the parentheses. And then we're gonna multiply by the derivative of u. The derivative of u is 2. And there you go. And then you can just clean this up by saying 2 over the square root of 1 minus, and then expand this will be 4x squared. So pretty straightforward, right? Just do the formula, right? Next one is going to be the same thing. The arctangent of 3x. Choose the proper one. So this is going to be this. In this case, u is a function of x. So in this case, it will be 3x. So following the rule is going to be the derivative of u, which is 3, over, right, 1 plus u squared. 1 plus u, and then square it. U is 3x. So then, therefore, when you expand that or you square that, that's going to give you 9x squared. And that's it. Now, remember, you cannot cancel those two because that's not a factor of the numerator. It's a factor of one term of the denominator. So just FYI. All right, so what about this one? Well, this one, maybe we should rewrite this one. We should rewrite this one as x to the 1/2, right? So when we're doing this, we'll get to do the derivative much easier. So we're going to do the u in this case is u to the 1/2. So when we do this, we're going to focus on the bottom part first, right? We're going to use the arc sign, so it'll be 1 over the square root of 1 minus u squared. Well, what is this square? If you square that, that's your u. If you square that, that's going to give you x, right? And that's how we got the x. Well, what about the top? Well, the top is just the derivative of this. If you take the derivative of this, it will be bring down the power to 1/2, leave the x as it is, and then take away 1 from the power. Now this one has negative power, so that's going to go to the denominator right there, and this is a fraction, so the 2 is going to go to the denominator. So that's what we got here. We could multiply this inside the square root because they're both square roots, and this is a multiplication. We can do that. So therefore we get multiply this times this. Because this is grouped together by the square root, you have to distribute that in there. And that's what we got for that one. Now we can be more creative, right? And we can throw even more things, such as the secant e to the, if we have this as being your u. And obviously we're doing arc secant. So we're going to try use this formula. So it'll be u factorial. Sorry, u absolute value of u, which we already know that this is always positive. So we can drop the absolute values, right? We can drop the absolute values. And then it will be the square root of u square. So that's your u square minus 1. And then this is all under minus u minus wait, there's a little typo here. There's a typo here. Let's see which one. All right, so it's r secant, r sine. It's, I believe this is going to be secant. Yes, I think this is the cosecant. Yep. All right, and then so we're gonna try. So the secant is gonna be a positive. So we're gonna go ahead and so yeah. So let's type it in here. So we have our. Let's rewrite this one right here. So we're gonna write it as cosecant. So we're gonna type it in here. So it'll be arc cosecant of u, and that's the one with the negative. Perfect. Okay, so that's supposed to be our cosecant, and so the secant is this one. So this is your u. Take the square root, u square minus 1, and then multiply by the derivative of u. The derivative of u is itself multiplied by the derivative of the power. So it gives you that. All right. And again, because we know any exponential is always greater than 0. All right, so this summarizes all the rules that we done so far. The elementary function is a function from the following list, or one that can be formed as a sum, product, quotient, composition, or function of this list. So these are the algebraic functions, the polynomial, the rationals, functions involving radicals. So these we use the combination of power rule and quotient, and then we have some transcendental functions. And for those we had the logarithm, the exponentials, the trigs, the inverse trigs, So we have summarized a lot, or we have already defined a lot of the functions available that we are familiar with. And so here is a quick table of all those rules, right? We have the derivative, we have the logarithms, we have these signs, and then here we added a few more, addition, division, the exponentials, and the trig. Right. So here we're done, but I'm gonna show you guys how we are able to come up with one of the rules here, right? That's one of the trig, the derivative of one of the trigs. And what we're gonna use here is we're gonna use the previous result from the last section that says that the derivative of the inverse function is 1 over the derivative of the original function of the inverse function, right? So I'm using that formula, but what do we need? We need to know what's the original function. The original function is f of x, which is sine of x. Then the inverse function of this will be arcsine of x by definition. Now what I'm going to do here is I'm going to take the derivative. I'm going to take the derivative of f, which is cosine, and then now I'm going to begin, right? I'm going to say, okay, by definition, the arcsine will be 1 over, right, the derivative of the original function, which is cosine, and then as an input, I'm going to have the inverse function. So here's my cosine, and as the input, I'm going to have my inverse function. So there you go, right? So I use the same definition. Now I'm going to try to simplify this, and it's just going to require some basic algebra, but this is it, right? This is it. This is the derivative. It just doesn't look nice. It doesn't seem practical to use. So what we're going to do is we're going to do some algebra manipulation, right? So what I'm going to do is I'm going to say, okay, well, I could square root this if I square this, right? Because the square root of the square root is the same thing, right? They're going to do each other. So I'm not doing anything. I'm just squaring and then taking the square root of it just for algebra manipulation. But it's still the same thing. So by doing that, now I have a cosine, right? But remember that I have a cosine of an angle, right? Now remember that we have a theorem which says sine square of x plus cosine square of x equals 1. And then if you subtract both sides by sine of x, subtract sine square of x, subtract sine square of x, that gives us cosine square of x equals to 1 minus sine square of x, right? So whatever's in here, I'm going to put in here, and I'm going to use this identity. And if you guys notice, that's what I have here. I have the cosine of square of something, right? And I'm gonna rewrite this as 1 minus sine square, and then replace and then keep the same inside, right? So that's what I did here. And then obviously I didn't do anything with the square root, right? I want the square root there, or I can't do anything with the square root. But if you guys notice, I'm going to rewrite this as this, right? Remember that sine square of an angle is the same thing as, by definition, it's actually this, right? Right, that's the definition. So I'm going to remove that square, or not remove it, but I'm going to rewrite it outside. And so what we have is sine of arcsine, everything square. Well, we know that what happens with those two is that these are inverse of each other. They give you back x. And so then you're left with the square there. And so you're left with 1 over the square root of 1 minus x squared, which is what we wanted. So there you go, right? So we found it. Now, obviously, if you have u there, then it changes everything up, right? Because then that's a function of x, and so you're going to have to multiply the end by the derivative of u, right? So it's very simple for us to change this into terms of u, right? All right. So that's it for this section. Our main focus is to be able to be familiar with how to evaluate inverse functions, how to take the derivative of inverse functions, how to how both the arcsine and the sine connect to each other, what's the relation between them. You have to be familiar with the domain and range of them. Obviously, be very familiar with the derivative functions, as we have seen here. Okay. All right. Hoping that this is helpful. Please let me know if you have any questions. I'll see you guys next time.